So our parts, we collect data typically all the way at the edge of these eval boards, and we include matching in between the connectors. Sometimes customers want to do their own matching and they have their own custom application. So rather than having references to the edge of this board, we want to go all the way to where the part is. So in order to do that and get our S parameters, we have to use what's called port extensions in the network analyzer. That basically rotates the reference plane from the edge of the board all the way to the part. And I've already set those up. I can go real quick. On this particular Keysight network analyzer, we have a port extensions function that we can do auto port extensions. So it's pretty simple. You can select which ports you want to use for the port extensions. I have port 1 and 2, port 1 on the input, port 2 on the output. And you would have to remove the DUT and remove all the components that you would have in the matching, and basically just put 0 ohm jumpers or some kind of jumper to get all the way to where the part was. And so you can measure an open, which means the part is off and it's just into an open circuit. And you can measure short, where we actually put 0 ohm shorts to the ground slug. And it's another method of getting the extension. And the analyzer calculate all the delays that it would take to get those extensions. So once we have that, I'll put the part back on using those extensions in the system. And right now, that's what I'm doing. I'm recollecting S parameters as if the reference plane is at the part. So, yeah. I'll hook this up real quick. This particular part, and most of our parts, have a choke inductor that goes in through the output port. So in order to get the bias to the part, we have to use a bias T from the network analyzer. So that's how we're getting the part to fire up without the choke inductor in place. This is 5126. It is a 5G infrastructure part, pre-driver, and it's pretty versatile. It can be tuned from a little bit below 2 gigahertz, 1.8 gigahertz, all the way up to 5 gigahertz. We've had a request to see if we could push it further to 6, and it looks like it can get there with some degradations. So trying to see how much gain I can get out of it and as much power as I can get at that frequency. But it's a pretty broadband part that can have several custom tunes as needed.
2 hours later.
All right. It turns on. I have this band sweeping from 4.3 gigahertz to 7. So I can The idea is to take those S parameters and I can pull them into simulation software. We use ADS and use matching elements in coordination with these S parameters to try to get as good of a match as we can across any section of this bandwidth. It's not going to operate at that full 100% bandwidth, but we can get subbands across that section. So I am going to just save S2P and I think it saves like 1,600 points, so should have enough data points to do my simulation. Because this is a two-stage device, so there's an interstage VCC as well as a final. What I'm doing instead is, for this particular tune, there's just a shunt capacitor that I slide along the interstage trace, of the VCC1 trace. And I'll look at a couple of different locations of that and have a separate set of S parameters. So further away from the part, I could tune the maybe 4 to 5 gigahertz range, and then as I push it closer to the part, I can go higher in frequency. So ideally, we would put a little pigtail on the board, do another port extension, and then you would have freedom to optimize all three. But in this case, this is more of a simple interstage. Other parts, we may have an inductor feed that we could try to optimize that inductor. This is purely a trace, as low inductance as possible for these high frequencies. So it's probably not necessary, but it could certainly help to optimize. One other thing about this part, it has a low gain mode, and I probably should have captured the S parameters before, but I will do it on this particular location. So it can operate full gain or about 5 to 8 dB lower gain once this gain mode is enabled. Now I have files that I need that I can use for simulation, as well as share with customers if they want to use it in their simulations.
Thank you so much for watching. If you'd like more information, please email us at sales@guerrilla-rf.com. And don't forget to subscribe to our channel for more content from Guerrilla RF.